So now start the 24-hour clock using counter. So for this purpose we are first go through the previous parts. Lab 9 part 1 we are discussing traffic light using conventional method. Lab 9 part 2 step method, traffic light using step method, and part 3 BCD converter. And in part 4 we are discussing 24-hour clock using counter. The counter may be retentive counter, it may be non-retentive counter. Retentive counter range from C0 to C199, and retentive counter retain its value after electrical failure, and non-retentive counter range from C200 to C255, which will not retain its value after electrical failure. So now start the 24-hour clock using counter. So you are using open contact and connect it to the counter. Counter is C0 and its present value is preset value is 60. So use open contact of counter C0 and connect it with the clear button of counter. And now connect X0 as an open contact parallel with counter C0. In rung 1 use X1 connected with the open contact of M1922, and this relay is connected to the counter C1. Preset value is 60. Pulse for counting. For counter we are using C0 parallel with these two contacts, and clear the C1 counter by using C1 counter. By using C1 counter as an open contact. Now use X2 in rung 2. which is connected with the open contact of M1922, and it is connected with the counter C2. Preset value is 24. Using C1 as an open contact, and clear C2 by using C2 counter. And clear the counter C2 by using open contact of C2. Now using the multiplicative function, in rank 3, and the shortcut for multiplicative function is 13. Two value is required for multiplication. Counter C1 and the SB value is 100, and the result is stored in D register, which is R0. Destination register is R0. We are using function 11, which is the addition function. For SA we are using R0, and for SB using counter C0, and for destination we are using D register using, and the result will be stored in R1. SA mean first value, SB means second value, and D is the result, where the result is stored, where you want to store the result. In addition, SA R0 value is used and counter value is used, it is stored in the D register. Now we are using move function. The move function The shortcut for move function is 8. Source value is R1 and destination value is R2. So we will close this move function by using close contact of x13 and now use the open contact of x13 which is connected to the move function. The source value is counter C2 and destination is R2. Now in the next run we use BCD function, binary to decimal conversion. It is on 20. Source is R2 and destination is R3. And at the end we are using 7 segment display which is on 7 segment scan output using the R3 OT by2. It is not 16 bit, so 8 bit, 16 bit and 32 bit. First 8 bit we are using 0 and WR using that 30. So we complete our 24-hour digital clock. So we have to simulate it. First of all of it. So now we have to run so this relay will count up to 60. Due to 1922 internal relay, the counter will move up to 60. And look at here, counter value is 42, 43, 44, 45, 46, 47, 48, 49, 50, 60, and when it will 60, C0 will on because it clear the C0, so C0 is used to clear the counter, and same as here, it will count 1. After 60, it will count 2. Look it here. After completing again 60, this will reset the counter, and yeah, 60, this counter will be counter 2. Now we have to on this on x1, on x2, so now look at here. When it is 1, when x1 is 1, it will start, this will the x0 reset the x0 reset the counter C0, and it will move toward the this counter. And now when x2 is on, it will move toward the counter C2. It will count toward up to the 24. This counter C1 value is added to the 100 value, is multiplied with 100 value, and the result is stored in R0, and then R0 value is added with the C0 value and it is stored in the R1. Move the value of R1 into R2 and C2 value into R2. And convert the R2 value into decimal and store into R3, and it is displayed on seven segment display. We are using status monitoring. X1, X2, X3, C0, C1, C2, R1, R1, R2, R3, So from your manual you can also reset counter C to reset counter C0 to 60. The counter value move from C0 to 60 and relay provide a 1 kHz pulse to the clock input of counter for counting up. C0 on, X0 on, and counter C0 is reset. Then the first rung is used for the generation of clock pulse and second is used for the counter minute to 60. It will count as 60. The first run is used for second and the second is used for 6 minutes and the third run is used for hour value, shift minutes value, left 2 digit. The run 3 shifts value, left 2 digit and add the R0 with C0 and then multiply C1 into 100 plus C0. So X13 time format control is off. Move R1 to R2 for display minutes and second. When X13 is on, move counter 2 to R2 for displaying hour. Convert the binary data of R2 into BCD data and store it into R3. So X0 is a second reset and X1 is the minute adjustment for minute adjustment and X2 is for the hour adjustment and X13 is for time format. X13 is for time format. Second adjustment, minute, hour and format. So that is the end of the experiment 6-2.